This is your host who is very, very, very frustrated with computers right now. Every piece of hardware in the building has... every piece of hardware in the building is completely not working. First of all, the Bluetooth headphones are not working. The router required rebooting multiple times after being replaced. Brand new piece of hardware straight out of the box. Yeah, this is not a good day for computers in the apartment. And then finally, the microphone is acting up. Can you hear me? Please let me know if you can hear me. If you cannot hear me, then I'm going to have to adjust some things. But let's plow on, assuming that you can hear me, and hopefully this goes well. So let's go to the usual spot. So I'm going to be doing these in chronological order rather than optimizing for leaderboard position. I know that I would potentially have a shot at getting top 1,000 if I were to start day 13 now, but I'm not going to do that. Instead, I am going to start with day number 12 and work my way forward. Hopefully that works for folks. So let's go ahead and get my templates going as usual. And then over here, let's do the usual. And that way I have a clean slate before I go ahead and start writing any code. Oh dear, that is going to be dreadful to read from that distance, but somehow I'll manage. Just make sure that works. Great. Okay, so without further ado, let's go ahead and pop open day 12 and read the challenge. We're in the year 518. Thoroughly hated caves to the left. Okay, we've got an infinite timeline. The initial state. This is, oh god, this is just Turing machine tape. Okay, great. We've got Turing machine tape. Pots on either side, yep. Okay, so we've got some rules to evaluate, and we have, yep. Okay, yep, these are just Turing machines, essentially glorified Turing machines. Also, there appears to, let's see, okay, I think that looks totally reasonable. After 20 generations, what is the total number of pots which contain a plant? What's your initial starting condition? Initial state, from 0 to the right. Okay. So let's go ahead and read our input. So we're going to have to read the first line, and then after that we can, the first 2 lines after that we can move into reading the pots. Great. So we'll just go ahead and paste that in. That looks totally reasonable. And now let's go over here and have a look. Okay, so, so the for loop, I'm going to need to read the first 2 lines, and then after that we will proceed. Great. Like that. Okay. So fortunately I can just split this and look for the third word, so that's fine. And we're just going to, let me think about it. Honestly, my inclination here, I know this is boring, map from int to bool. That is easier than dealing with infinite cardinality, so we're gonna just do that. We're gonna do this. Pots is a map from int to bool. Okay, so let's see, 4. Okay, we're going to need strings here. We're not going to need strconv. Okay, perfect. Okay, so initial color, something like that. Index number 3 should produce what I'm actually interested in. For C, okay, something like that should do the trick. If C is the character that then true. After that, we're going to read some rules. Okay, so let's just make sure that POTS looks fine. So let's run that and see what happens. Cannot assign to initial index I. Oh, whoops, not initial index I, that's POTS. Okay. Does that look reasonable? Great. So what's going on here? Okay, let's just make sure that looks okay. No, that does not look okay. Why does that not look okay? Oh, whoops. Right. Unfortunately, this text is in red, and I'm using a projector rather than a monitor today. So I would explain why we're having these troubles. Okay. We've spent a minute flailing in a circle. Okay, number 12. Okay, there we go. Day 12 got input. Try that. Okay, that looks fine. Lovely. Now let's find out why we're out of range. Line 27. Why is line 27 wrong? Okay, string split. Just make sure that that produces results that we expect. Okay, that produced the empty list. Why is that? Let's just make sure that we've done this correctly. Split S separation string. Okay. Huh. It's very strange. Oh. Because of this problem. There. That's my problem. I think I need to do that. Does that work? No. What did I do wrong here? All substrings separated by the separator. I'm pretty sure this separator is an ordinary space. Oh, yeah, okay, that looks... Oh, because I need index 2, not 3, that's why. Oh, the ways that programming makes you feel very silly. Okay. Great. That looks completely reasonable. Okay, I believe that now. So that's good. Now I need to read the patterns in. Okay, so the patterns are going to go... all of my patterns are 4 characters, but pot that contains that pot and a pot on 2 sides of it contains a pot plant, but with no plants within 2 plants of it. Right. I guess the thing that's confusing to me is this input here. Oh, I see, the projector's just clipping the edge of it. Okay. Projectors are annoying. Film at 11. Yeah, okay. So 1, 2, 3, 4, 5. Yep. Okay. My bad. Okay, great. So what we want to do is I want to pattern match. Also, is it possible for multiple patterns to match? No, it isn't. Okay. Great. So let's do this. Okay. Yep, that seems fine. Okay. Pattern struct. Let's see. 2. Pause 1. Yeah, actually, we'll call them left. No, I think neg 1, neg 2 makes clear that it's neg 1, neg 2, and pause 1, pause 2. Okay. Neg 2, neg 1, self, pause 1, pause 2, cool. Okay, that seems fine now. Maybe slower than using a pure bit mask, but I care more about readability than speed right now, unless I have evidence to the contrary. Okay, great. So here we have our pattern. So we're going to be reading through each of these and extracting the pattern. So parts is going to be string split L space as usual, and we're going to throw away parts index 1. So it's just parts 0 and parts 2. Okay, and that's just going to be if parts result is going to be not result, but next gen is going to be parts 1 equals that. I think that's fine. Okay. So okay. Neg 2 is going to be okay. Parts 0. Neg 2 is going to be parts pattern next 0 and pattern next 1. Okay. Those are going to be room characters rather than full strings. Yeah, that's fine. Okay, that looks okay. Something like that. And then finally, okay, so now we can set patterns. Pattern 2, neg 1, self, pause 1, pause 2. Close curly brace, close bracket, equals next gen. Okay. let's make sure the patterns look reasonable. So we'll print that and see what happens. Okay, let's look at 1 of these. 1, 2, 3, 4, 5 equals, yep, okay, so true, false, 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 false goes to false. That looks fine. Okay, so we have now accurately conveyed this. Great. Okay, now we're going to iterate over the tape. And what we're going to do is, how do I guess the other question is, what do we do about the rest of the infinite tape? Let's look at the input. V12 input. Let's see. So if I have all dots, then I always go to dot. So I'm just going to remember that because, and assume that that's an invariant. Otherwise this becomes, we'd have plants growing from basically everywhere. Okay. So now, we need to keep track of the minimum index that we've set so far. Min alive. So minimum index alive initially can be no more than 0. Max IDX alive is no more than, or is no less than length of this thing here. So I'm going to have to save this. Okay. Okay. That's good. Okay. I think something like this should do the trick. Okay, so now this sets appropriate bounds for us to check. And if we ever set a pot to less than the min IDX or more than the min max IDX, we can change that value. Okay, great. That way this doesn't grow too far without limit. Now, we are asked to print out the number of pots which contain a plant. So that's easy enough. That is going to be pots. That's going to be okay, or %. Great. Now we need to run the loop for 20 generations. So I think my suspicion is that the the min IDX and max IDX that we need to keep track of. Okay. So let's see. For x is, if that makes sense to call gen. Because it's not dependent upon generation, I'm not going to wind up typing that a lot, and that way I can use I for this. Okay. Minus, I need to start at least 5 to the left, 4 to the left, doesn't really matter, I think 4 to the left is correct. I is greater than, or is less than or equal to max idx alive plus 4. Oh, I see the problem here. I'm going to potentially have to clone the map. No, I'm not, because I can be smart. And yeah, I can. Yeah, I'll have to copy the map as I go along, and that's fine. Okay. Okay. This is going to be annoying, but that's okay. I plus plus. Okay. So now, if I, okay. So now we're going to take, yeah, for each of these we're going to, no, it's not 4. It's only offset by 2, because we always presume the center. Yeah, I think that's right. Okay. Okay, something like that ought to do the trick. Let's see. So now, pots of I minus 2. Okay. State is going to be, new state is going to be those 2 pots I minus 1, pots I plus 1, pots I plus 2. Fine. If you, let's not add extra accesses. New state. We got new state, and I is less than min idx then min idx y. Similarly, if new state and I is greater than max idx alive, then max idx alive equals 1. Okay, so let's run that and see what happens. That can't possibly be right. So let's feed in the simple input and see how that goes. Okay, that should do the trick fine. Input file equals input state 12. Simple input. The result should not be 11. The results should. Oh, whoops. Duh, I feel stupid. Okay. Through the end of that, hot equals. Pots equals new pots. Okay, and then we can garbage copy open that. 41, that is incorrect. Okay, let me see this. Max idx alive plus 2, that seems fine. Okay. Okay, let's run it for a small number of generations. we run it for 1 for 0 generations, there should be 11 pots alive. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Yep. Run it for 1 generation. It claims that there are now 30 pots alive. That can't possibly be correct. That's fascinating. Oh. Because we're changing this value. Okay. We need to keep those values static. Now it should be more reasonable. That still is yielding 30, which is clearly wrong. Pots equals new pots. New pots of I. Doesn't even make sense. How many times is this running? That's really strange. Okay, we'll try